Hi everyone, this is Gierki, and today we are talking once again about optimizing an open world in Godot. We are optimizing meshes, so even small changes in the LOD models have a big impact. So here I'm working on the trees which I'm using in my open world game, and somebody asked in the comments if I have modeled them myself. No, I haven't. I downloaded them for free. But it doesn't mean that I don't have to touch them. I mean, you have to understand that we are using every single mesh here multiple, like thousands of times, right? So we need some proper LOD models and we need to optimize them. Like this tree is the perfect example that we don't need this amount of vertices, like 2200. It is already low, yeah, it's low poly, but we can still improve that. You have to understand that for every single tree we have a shader, and every shader has a vertex function, or some people call it vertex shader. So what a shader does is he's going through every single vertex and is calculating its position. Like for example, if you implemented wind, so it's calculating its position for every vertex, right? So what we want to do here is we want just to minimize the amount of vertices, so the model still looks decent, but yes, it still look decent, but with the minimum amount of vertices. Okay, so here all of those I have already done, and here is, for example, the comparison. If we look at the vertices, actually the lines are better here, the edges. This is much less poly than this one. There is going to be a texture anyway on those, so you won't see the difference. And yeah, so let's see what this tree here has to offer. You can look at the vertice count if you want, how much it's optimized after I'm done with that. But if you look, for example, only at the branches here, at the end of the branches, you see what I mean. Like, we don't need 20 vertices to get this effect, this visual effect of the trees, of the branches, right? So let's start here at the trunk. I think this tree is called Twisted Tree, so I'm gonna try to keep some of its twist. I'm not gonna make a perfect tree like you use it in in the industry, where every phase is only supposed to have only 4 vertices or stuff like that. I'm gonna let it do Blender its thing. I'm fighting with time here actually, so I want to do it as fast as I can and as efficient as I can. So here we already see that we can pretty much minimize the amount. Here at the branches, for example, I'm gonna keep those loop cuts here because as the tree bends in the wind, we need this connection here. So those vertices need to stay where they are, so this branch here makes sense for the vertex shader. But as you see here, we can get rid of a lot of those vertices, especially here at the tippy toppies. Tippy toppy, right? I think I'm gonna fast forward that so I'm not wasting your time. Okay, so here you have it. I finished the trunk, and now we are at 1400. So, like I said before, the vertex shader is going through every single vertex of that, and you have to multiply it with every single tree that uses this mesh, like in a multi-mesh, for example. So, yeah, we are saving here a lot of performance. The next thing I'm doing is I'm duplicating that. I'm putting it in the back. This is my second LOD, and here this is something very easy. I'm just decimating it. So actually I'm just the decimator is just calculating and trying to keep the shape and just using half of the vertices. So that's for my next LOD. So for trees that are further away. And what I did here, because that's also something, an issue I saw with not only with that asset pack, but with a lot of them, that since those asset creators are not very concerned with performance, they are just throwing in these quads with an alpha mask, and if they feel that it should look more dense, then they are just throwing in more. The issue is that alpha is a very expensive thing in game engines. Besides Unreal, of course, Unreal has some miracle stuff going on in the background, but normally in engines you have the issue with alpha, since it is just for every single pixel in a fragment shader, he's calculating every single alpha what he's encountering, and since it's transparent, it's going through everything that he encounters. Like for example, let me demonstrate it quick. Let's say I want to calculate this pixel here, so I have to go through this face here, that one, 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 that one. Oof. And yeah, still going. And we're done. So how many faces have it been? Have you counted? Write me in the comments. I'm curious. And that's the issue with alpha. So he's, let us see. So here you have the vertices now without that. And yeah, I hope you get the point. So what I'm doing with that is actually, and I have already done it, I'm taking the entire leaf crown, I guess, and I'm just selecting random, select random, and I'm just deleting it. So it's just a half. If I want to increase the density of those leaves, I change the alpha mask. So the alpha mask is let me show you. That's the alpha mask. Like you see here, this is not dense enough. You can just draw a different picture, like simulating more leaves, and it looks more denser just by changing the texture. So yeah, here I have already done it. So here we have 1000 vertices, and they are all infected by the vertex shader is working on them, and here we have the half. Yeah. So as I finish, I'm gonna finish up here. I think that was the last tree. I'm gonna show you in engine how this looks like. Okay, so here we are inside of the engine. I have already imported the assets. Easy to do. You just double click it, actions, save mesh paths. I have created a new folder here. This is the old one. I'm going to delete it in the future. And here I already exported. So you just have to click current folder. Then he checks everything and set path, import, done. So here in this folder, we have the proper names. You have to set the mesh names in Blender, so you get the correct naming here. This is my tree chunk, so this is what's generated for the entire multi-mesh system. It's a grid made of chunks, and every chunk has this controller here, which creates for every single mesh that we are using multi-mesh. So yeah, and it's managing which should be on, which should be off, so we can save performance wherever we can. So how do we set it up? I split normally it is like that you have a mesh and you apply the no the materials. Sorry for that. You apply the materials. The issue with that is that as soon as this gets imported, he's trying to use the materials from the blend file, and since you have seen in my Blender file how it looks like, that's not the materials I want to use. I just use them for just viewing it inside of Blender. I have my own materials here in Godot, and every single tree has their own materials for close and far distance. So we can, like here for example, this is the tree trunk close material. Okay, that's a bad example. But here with the leaves you can see that it's a temperate forest tree, leaves far, and here we have temperate forest tree, leaves close material. Since we want the like I said before with the wind, we want the wind to be applied at the close mesh, and we want to use alpha mask, and as further away we go, we are turning the, and it's everything is happening with the close shader. As further away we go, the less impact wind has on the leaves and the less alpha we are using. So in the end we are just taking the entire face, the entire face, and it's just a blank color. So we have a better transition for that, and that's everything what the close shader is doing, so we can save a lot of performance for the further away LOD. Okay, so let's set it up. We know the names here. Let's select the first temperate forest tree multi-mesh controller, and we have here just a mesh array, so it's saved in this file here. We want to use those new ones, so we just drag and, oops, that's boreal forest, that's a wrong tree. We want temperate forest here, 01 LOD 0, and as you see here in the preview, he's using the materials from Blender that I have, and that's why I created this array with materials. So as soon as this gets spawned in the game, he's taking those materials and applying to the tree. That's my optimization for that. So we just have to drag and drop that. He's still using the same materials, and yeah. The last one here is just the billboard. Yeah, I just, here we have my helper thingy, and here we have like a viewer for what I mean. So here is, for example, we use alpha. The further away we go, the more solid color it gets, and then it's gonna look like this tree here, for example. And the further away we go, then it's switching automatically to the billboard. So that's my 3 LODs for that. Okay, but this is already outdated, so let's stick here. I'm gonna set it up, and yeah, fast forward. Go. Okay, we are back in the game, and as we can see, all of the meshes are set up. We have the transitions between the lowest LODs to the highest LOD modes. Like I said before, the billboards are not set up. I have to do it manually, like screenshotting them. I mean, there is something called imposters, but they are not working as I expected it to work. Need to figure it out. Probably it's my mistake. Yeah. So here you have it. The trees are set up. We have LODs. Everything is now also set up with Blender. So in case there is going to be a change, like for example in scale of the mesh, it is updating accordingly inside of Godot without me changing that manually. That was horrible to do anyway. Yeah. I hope you like this kind of format. I'm still experimenting. This is, yeah, I'm not that experienced in making videos on YouTube, so let's see how you're gonna respond. Leave a comment I'm really curious if you would like me to do more of this kind of deep dives. And yeah, have a nice one. Bye.